Bismillahirrahmanirrahim. Welcome to episode 2 of networking analysis. Here we are going to just resume our discussion and what we are discussing in the previous section about the atomic theory. And remember, there are the two conceptual schemes that are actually in the present day. We are focusing on two basic conceptual schemes that are the base of the network's electrical theories, and the first one is actually atomic theory and a conceptual scheme. So we are going to divide the two schemes into two different episodes because the time for explanation of each and every step it takes time. So let's start with the atomic theory of the conceptual scheme. Two conceptual schemes are using today. First one is the atomic theory conceptual scheme. We are going to discuss this in today's episode. When we discuss the atomic theory conceptual scheme, basically atom comes in the mind. Okay, so according to this theory, first let's discuss the atom. This is the atom, which means there is a nucleus. This is the nucleus in the center. In every atom, this is simple and the general criteria that is suitable for every atom, not for the particular atoms. This is the nucleus. In the nucleus, there are the generally main terms are the protons and neutrons, which I give you a hint to remember the charge. N stands for no charge, so neutrons means no charge. Just a hint for understanding things, learning and keeping in your mind forever. P stands for positive, so P is equals to positive charge. So in the nucleus, there are the two things, proton and neutrons, and not going into so details, but just for this episode, I'm just saying that there are electrons that are revolving around in the circular shape. They're revolving just like our planetary model around the sun. Here the electrons are revolving around the nucleus of the atom, and the electrons carries negative charge. So for example, in an atom there are suppose 10 electrons, we simply say. So it means just we say negative 10 charge due to the electrons, and it means that there are 10 protons all must be in the nucleus to balance the positive charge inside the nucleus, while the neutrons carry no charge. They are neutrals. So it means that the protons and neutrons are equal. But if something happened, the outer side, we are going away from the nucleus more and more, the electrons in the outermost orbits are actually not tightly bound compared with the inner electrons. They're having very tightly held with the atom. Whenever an attack comes from here, like in the form of the energy, that is going to that have major impact on the outer, definitely on the boundary side first. For example, this effect of this energy that is coming here will be on the outer electrons, and the valence shell, this is the this electron will go into the valence shell, that is a conceptual boundary outside the atom. And then these electrons take part in the after the excitation state. These electrons will go and leave the atom, and these electrons become the free electrons. So according to the basically atomic conceptual theory, it is said that everything like not only metals, plastics or insulators, everything, conductors or non-conductors, is made up of, every substance is made up of the tiny atoms. Number of uncountable atoms are made up, joined together, and then somehow the substance is manufactured, or everything. All substances are pictured as made up of atom. Everything is made up of the atom. Okay, according to this theory, in a solid, some electrons are relatively free of the nucleus. means like that what I explained. They are going to leave and ditch this nucleus, the overall atom, and then can be said that because they are free from the atom, they have no nucleus, they have no shells, they are now take part in the movements because they're free, they can go anywhere, they are basically taking the participation in the motion, in the movements of the conductor. The more and more these electrons, which means that more are the chances of the movements. So such electrons are basically have a particular name called free electrons, and these are very important free electrons. The derivative of the charge with respect to time, like derivative of the dq charge, q is the charge, with respect to time dt, what we discussed in the previous episode. Here in the previous episode we convert that charge with respect to time. We defined it this term that this is called current, but in the previous episode, if you remember, we replaced the electrons via the conversion into the electrons. So here we can simply say d electrons divided by dt. I'm just writing here E for the case of the electrons. That basically electrons that we mentioned in the previous episode, like 6.02 into 10 raised to the power 18. Basically these electrons, what are these electrons? There are two categories now. We in the previous slide discussed the electrons, but of the different categories, like the category 1 electrons that are in the that are attached to the orbits and attached with the atom, with the nucleus, means they are not those electrons that are still in the orbits and still revolving around the nucleus. This is the first category, that are still bound to the stick with the nucleus. Second category, this is the second category here. Those electrons which ditch off the electron, get rid of this nucleus, those who are like in the excitation state. For example, this electron right now, this is an electron, this is in excited state, and this is called free electron. These are not called free electron. There are the two things. First category, these are also electron, but these are not free. They are already in the working. These are the free. They are available for different reactions, different responsibilities on them. They are able to move from one place to another place. Now, for example, this is an atom, this is a free electron. There are a number of atoms, because every metal, every solid state made up of number of atoms. So if there is another atom right here, and then one electron if leave the first atom, this is the first one, let's suppose, and this is the second atom, it will accept that, okay, due to the pressure coming from this side. Like, consider this case, this diagram. The energy is provided through an external source. Let's suppose the positive potential of the battery, just suppose. Due to the push of the charges here, the charges are coming, striking with the force on the first. This is the first atom, round shape. This is the first atom. The electron, this is the electron, come here, strike with this one, and this, due to this energy, one electron, from just for the understanding, one electron leaving this and leaving, after when the one electron leave the first atom, there is an empty space left in the orbit. The previous electron that was coming from the back side will fill this space, and actually his electron will be going to strike to the next atom. With the energy of this atom, this will take place, this will excite the one electron of the next atom, means now its electron is in excited state, become free electron, and it will take the place of this hole that is the empty space. Then the striking again, and it will be continued striking once and again. Means basically the electrons are passing from one atom to the next. They are not like that if one electron is in excited state, it is going to travel in the whole phenomena. No, means they are, if one electron is going from this, is excited in the excited state this through the first atom, the next atom is accepting the free electron of the first and leaving its electron for the next further movement. So movement of the million of these atoms, free electrons, move or take part in the charge. So these are the actual free electrons. For by the definition, so an electric current is the time, means definitely the time is the standard. For example, in the first second, we are counting the time, the rate of the flow of these electrons. For example, the first interval of the time, the flow of the electron is 1. So the next interval of the time, the flow of the electron is 5. So with the help of the timeline, times is the scale for the measurement of the current, we can define the parameters here, like in this context. So an electric current is the time, rate of the flow of these free electrons passing from one atom to the next atom. This is the main thing, one atom to the next atom. They are basically moving this sense. So it means that the free electrons are responsible for the movement of the current, charge, current overall in general term. So it means the more electrons in a specific material, the more movement we can can be seen. Like if this is a material, it consists of the atom that have more free electrons. So the nature of the every material is different from the other material. Like here in the diagram, you can see the inside this one, this is called copper. This is the wire that is made up of the copper. The outside boundary, that is called lamination, and there are the two opposite material. One is the conductor, that the inside copper. This is a very good conductor because why it is a good conductor? It is allows current to pass with minimum resistance, showing very minimum resistance to the path of the current. Because when energy is striking in the in this conductor like copper, it has excess of the atoms which have free electrons. They are starting moving free electrons, passing from one atom to the next free electrons. Then from passing through this phenomena, they reach to the other end, and there are excess of the free electrons, like gold, acid, salt waters. In the case of the liquids, salt water and acidic materials, acidic waters, liquids, mostly metals, and some liquids are good conductors. So in contrary to it, the lamination we are going to use for the protection purposes are definitely the material with relatively few electrons are known as insulators. Common insulators are glass, mica, plastics, etc. There are some other materials that lies in between the insulators and conductors. They are the semiconductor. They are very important categories. Right now at the spot, we can say the semiconductor is the base of the modern era, because we are, whenever we want the more behavior of the conductors, we can change their property according to our desire. Doping is very precise term. I explained all the things in the diode application season 1 and season 2 about the semiconductors and the role in the electronics. By the way, these are very important discoveries. Semiconductors and two important, germanium and silicon, are used, and most importantly silicon, but germanium and silicon both are very important. Because with the help of the doping we can control their specific properties. So this is the main reason why I am saying these are very useful and mostly used semiconductors. This is a base. So according to the concepts and the conceptual theory of the physics and different things, there is a common misconception that some electric waves propagate at approximately the speed of light. This is not misconception, sorry. This first part is actually the right thing, that since some electric waves propagate at the approximately speed of light, here this is good, no doubt, because when we are our communication, networking, satellite communication, with the speed of the light, these waves, electric pulses are moving, fiber optics too. But this is the misconception. Next part, the electrons in the conductor. We often after analyzing these things, this picture comes in the mind, that electrons in the conductor, in any conductor, maybe in good conductor like gold or any good conductor, travel in the same velocity. Maybe they can also travel with the high speeds, like speed of the light. If this conductor is a very good conductor, but actually this is not. This is misconception. This is called term called drift velocity. Remember that. We will be maybe going to explain when we need it, but right now you can simply say this is the speed of the electrons in the conductor. The actual mean velocity of free electrons is but a very few millimeters per second in a conductor. This is going to be proven in the coming lectures, and I am going to explain with the help of the numericals, but not right now. In the coming lectures coming soon, very soon. In a copper at 60 Hertz, velocity is equals to 3.2 meters per second. So this is the according to the Wikipedia resources, and this is the end of episode 2. In the next episode, we are going to resume our discussion from here this point and discussing the next portion and next strategy which are still we are using. This is the first scheme, and the next will be discussed in the episode 3. So stay tuned, watch, learn, grow. This is